Okay, good day everyone. So today I will show you how to use or the procedure on doing using the graphical method on velocity analysis for a four-bar chain mechanism. Okay, so the problem says that in a four-bar chain ABC, link AD is fixed and its length is 150 mm long. The crank AB is 40 mm long and it rotates at 200 revolution per minute clockwise direction, while link CD rotates about D, which is 80 mm long. Then it also says that BC daw and AD is equal, and the angle created by the link BAD is equal to 60 degree. So we need to find the angular velocity of link CD. Okay, so the first procedure is you need to create a space diagram using this data here. Okay, so the first thing to do is to set a scale, a suitable scale for your drawing. So you just need to select a proper scale na pwede na to siya i-drawing diri sa atong paper. So let's say for example that I use a scale of 1 centimeter equal to 25 mm. Okay, so with that we can convert now the length of each link into this using this scale. Okay, so for link AD, it also says that link AD and BC is equal now, which is 150 mm. We just need to divide this by 25 mm. Therefore, we can have 6 cm. So this is now the dimension that we will use in drawing or creating the space diagram for this mechanism. Now, next thing to do is convert again the other link, which is like CD, 80 mm divided by 25, so it's equal to 3.2 cm, and AB is equal to 40 mm divided by 25 mm, which is equal to 1.6 mm. Okay, so if you have the dimension now, you can now create the space diagram. Okay, to create the space diagram, you just use this dimension. So just measure, let's say for this example I use 25 mm as a scale. 1 equals to 1. So just measure first this 6. So this 6 now going to this point. Okay, that's 6. That is point A, and this is point D. Okay, so you can, if you, let's lang use a ball pen to make this even clear. Okay, that's 6. So this is point and D. Now, after you create this first link, we always start with the fixed so that it is easier for us to draw the space diagram. Now, next, as mentioned here, that the angle between B, A, and D is 60. So we just need to create angle for having with the center of center as a 60. So therefore 60 is around here. So just create a line. This is line. Okay, this line, we know that this line is dari nato makita kung asa karon ang atong point B. But point B daw from A to B, the distance is 1.6. No, this is this is centimeter. We know that it is 1.6 centimeter. So just measure 1.6 centimeter along this line. So it's one maybe here. Then just make it clear. Okay, so this is now the point B. So this is now to draw C. We don't know the location of C, but what unsa lang naa nato is we know that from B to C, ang length niya is 6 centimeter. So you just need a compass for this to draw or to locate the C. Just measure sa imong radius sa imong compass karon. Ang radius sa imong circle is 6. Okay, that's 6 centimeter. Now, using point B as your axis of rotation, we know that this length now is 6. Okay, the 6. Just create an imaginary or a circle or an arc. This arc now. Then, next thing to do is create again an arc for this distance from D to C, which is 3.2. Okay, just measure 3.2. 3.2 is around here. Okay, that's 3.2. Then your axis is this point D here. Now, the point of intersection, which is this point here, this is now the location of point C. So you just need to connect by a line. Okay, connect it by a line. Okay, now this is now your point C. So we know that this is fixed here. This is a fixed link, and this is now so we're using a scale of 1 cm equal to 25 mm. Okay, so the next thing to do is to calculate the angular velocity using the available data. Okay, from here we know that to convert the angular atong revolution into angular velocity, we can use the 2 pi n over 60. Okay, so we just need just to specify that this angular speed is from link AB. So 2 pi, which is 200 revolution per minute over 60. So therefore you have 20.943 rad per second. Okay, so this is now your angular velocity. Now, we know that the relationship between the angular velocity and the linear velocity is just equal to V equal to R W. Now, so what we're trying to do now is to look to determine the linear velocity of this link AB. Okay, so to calculate that, we just need to specify that this is the angular velocity of this link AB. Then its length, substitute lang nato by link AB multiply by angular velocity of AB. So which is the length of this is equal to AB is 40. So just need to convert that into meter, multiply by the angular speed, which is 20.943. So therefore you have a speed of 0.8377 meter per second. Now this is your speed for AB. Okay, we know that point A has a zero velocity, so therefore the speed of point B is absolute. So we can say that the velocity of B is just equal to the velocity of B relative to A equal to 0.8377 meter per second. Okay? So after that, after you determine one velocity, so you just need to create again the velocity diagram using this figure here. So in creating a velocity diagram, we need to set a scale again for our velocity. Okay? So let's say for example, because we're doing a graphical method kasi. So let's say for example that I will use a scale of 1 cm equal to 0.2 meter per second. So this is the dimension or the scale that will reflect in your velocity diagram. Okay, so in velocity vector diagram rather now. So you just need to divide this value here in order to convert this value or the linear velocity of b in a vector diagram form. Okay, so this is the value. So just convert it, v or just velocity ba is equal to 0.8377 meter per second divided by 0.2. So you have 4.19 centimeter. So this length now is the length that will reflect in your vector diagram form. Okay, so in creating this, the first thing to do, next thing to do is to locate all the points in your mechanism that has a zero velocity or a fixed point. For this example here, the fixed point is point A and point D, which means that point A and point D has zero velocity. So therefore, if zero velocity siya, you can combine these 2 points in your vector diagram because isa lang man sila og velocity. Okay? So just make a point, then this point will show that this is the point A and D. Okay, so this is the point A and D now. So we know that the linear velocity is always will act perpendicular to the link as mentioned by the previous na to nga discussion. So it always act perpendicular to this link, perpendicular to the link. No, every linear velocity there will always act perpendicular to the link. So we just need to create a perpendicular line for this point, a perpendicular line for this this link from this point here. So you just need to do is use your roller. If it is the line of action of this roller of this link here, use this triangle. Just move and locate that point. Okay, the location of it is here. Okay, just draw an imaginary a temporary line from here. Okay, so now we know that it is this line now is the perpendicular of this link here. So you just need to measure 4.19 for this. 4.19, so maybe around here. Okay, so this is now your point B. No, use a small letter if naka sa vector diagram. Okay, so therefore this is now the equivalent of the linear velocity of point B in the vector diagram. So this is the speed, that is the velocity of B relative to A. Now we need to calculate this the velocity of this link. Okay, so wala tay value, so we don't know asa dapat siya mo-occur, but ato lang available that we know that the velocity, the linear velocity of these two link will always act perpendicular to their link. Okay, so again, draw. Maybe let's start with okay, so let's start with this link BC. So draw the, use your ruler as support ninyo, no? Then use your triangle. Okay, so we know that BC is connected to kuan. So we will draw a perpendicular line from this point A. Okay, atong gi-create man karon is BC man. Okay, so kabalot nga ang C is connected to B. So this is point D, this is point B now. So we need to create a perpendicular line for this, from this point to the kaning link. Okay, so draw, use this and use your ano. I used this 30, 60, 90 because na siya perpendicular line daan. Okay, so just cross ano. Okay. Then draw a imaginary temporary line rather. Temporary line. Okay? Next, if this is the if this is now the, we know wala ta kabalo kung asa nga point mo occur, asa dapit ma-locate si point C diri. But we all know that ang point C is naara gyud diri siya nga kaning line. Okay, no? Nag-false ra siya nga line. So ang buhaton nato sunod is to create a perpendicular line for this link to locate this C from D. Okay, so create a perpendicular line for this link here. So again, use your ruler and create a perpendicular line. Okay, so perpendicular line to point D. So this is point D. Giisa lang nato no ang point D, and then draw a temporary line for that. Okay, so now if you have this, you just need to find the intersection. Okay, again the same with the drawing as we gidraw nato ang space diagram. The intersection of the link BC and DC is the location of point C. So from here, this is now the location of point C. So you just need to connect this point here. Connect the point, then connect this point here. Okay, so this is now your C. Okay, so this is now your velocity of B, or velocity of C. Velocity of C relative to B, and this is the velocity of C relative to D. Okay, so the next thing to do is to measure its length. Okay, just to measure the length so that we can, okay, kabalo man tadaan diri nga part nga equivalent ani is 4.19, which is the velocity of B relative to A. So we just need to measure unsay dimension ani niya. So measure nato, it's around, I think it's 1.6. So depende sa mo na kung sa mo nakuanda. But for sa ako, its velocity of C relative to B is 1.6 cm, and the velocity of C relative to D is, let's measure this class, it's 3.2 centimeter. But we know that our scale is in every 1 centimeter na atay 0.2 meter per second. Okay, so therefore if we will multiply this by 0.2 meter per second, we can have a value of I don't have a calculator, no? So sige na lang, 0.2, 1.6, 0.2, 12, 2, 3, so 0.32. So you have 0.32 meter per second, and this multiplied by 0.2 meter per second is just equal to 3.2 times 0.2, 4, 6.64. So 0.64 meter per second. But the problem asked you to find the angular velocity of link CD. So which is this? Nalantay ka, ang gihatag lang, ang nakuha lang nato is a linear. So therefore, using the relationship, therefore the linear velocity of link CD is just equal to length CD multiplied by its angular velocity, which is 0.64 equal to, ang length nato sa CD is 80. 80 divide 1,000 times WCD. So we can now find the angular velocity of CD using this one. Okay, so it is in terms of rad per second. Sorry, I don't the calculator, but you just 0.64 divided by 0.8. So I leave that to you to solve the velocity of or the angular velocity of C relative to D. So I hope that everyone understand the procedure. Then for the next video, we will have another example for this. Okay, thank you and goodbye.